The purpose of this video is to provide some examples similar to those that you will encounter in Homework 8. First of all, you can and should use StatCrunch, not the computational formulas, to work all problems in this assignment. This will make it easier for you. You can certainly check your answers using the computational formulas, but you're probably going to get more accuracy if you use StatCrunch. The first problem. Write the null and alternative hypothesis you would use to test each of the following situations. A team of surgeons developed a new surgery technique for a risky eye operation to restore sight using the old technique. The success rate was only 30%. The surgeons are hoping that the new procedure will have a success rate that is higher than 30%. So it's about proportions. The proportion or the success rate for the new procedure equals 30%. Remember, the null hypothesis always says nothing has happened. It's the same as the old procedure, and it always includes an equal sign, not an inequality. Since the wording of the problem points us in the direction that they're hoping that it is higher than 30%, the alternative will say that the success rate of the new procedure is greater than 30%. A second scenario. In 2004, the U.S. Department of Transportation reported that 77% of all fatal auto accidents involved an intoxicated driver. A random sample of 5,230 accidents in 2008 showed that 79% involved intoxicated drivers. Has the percentage changed? So the null hypothesis is going to say nothing is different. The percentage is still what it was back in 2004, namely 77%, and it will include an equal sign or is. The alternative will say that it is different, that it has changed. We're not going to put a greater than or less than because nothing was specified in the statement of the problem. Third scenario. Researchers believe that eating a healthy diet, emphasis on reduces the risk of bowel cancer. In the general population, about 10.9% of the population has had bowel cancer sometimes in their life. So have things changed? The null hypothesis is that the proportion of persons who eat a healthy diet still have a 10.9%. There is nothing different in their proportion. And we're going to use a less than in the alternative because the statement of the problem points us in the direction that a healthy diet reduces the risk of bowel cancer. Second problem. In the year 2000, 53% of Massachusetts residents wore seatbelts while they were in the auto. A click-it or ticket law was introduced in 2005 requiring the use of seatbelts. A recent test to see if seatbelt usage has increased got a p-value of 0.09. Is it reasonable to conclude that the new law was effective in promoting the use of seatbelts? Well, the p-value they got was 0.09, which is greater than 0.05. So we would not be able to reject a null hypothesis of a change in the use of seatbelts. So the conclusion would be it is not reasonable to conclude there's an increase in seatbelt use. The p-value cannot suggest a conclusion because to do so it would have been less than 0.05, and it is not. A news article reported that less than half of all Americans attend church. A recent poll of 1,785 randomly selected adults found that 750 said they attend church regularly. What's the null hypothesis and alternative relating to this article's claim? The article reports less than half, but the null hypothesis is always inequality. It says that it is actually equal to a half. The less than comes into the alternative hypothesis. We'd like to see, can we reject this hypothesis of equals a half and go with the alternative of less than a half? B is wrong because a null hypothesis always has an equal. Same problem with D. Same problem with F. The problem with C is the not equal to when it should be a less than. And the problem with E is the greater than when it should be a less than. Second questions. Are all assumptions and conditions met so that we can conduct this test of inference? And the answer is yes. The things you need to check are 4. Independence. Whether one person goes to church or not, does that impact another? No. Are the subjects selected randomly? Yes. Does the sample consist of less than 10% of the population? Yes, the population of all Americans is huge. And what about the success and failure condition? There's a little typo here. This should say p hat or sample p. The sample p is 0.42. 1 minus p is 0.57. And when you do n p hat, 1 minus p hat, you get that they are both greater than or equal to 10. So the sample is certainly big enough. Do you think the news article is correct in that the proportion of churchgoers is less than 50%? Well, let's go ahead and check the null hypothesis and alternative that we constructed in Part A, and we're going to use StatCrunch to do that. We're going to enter, we're going to enter the number of churchgoers, which was 880, out of the total population, the total sample rather, that was 1758. And we get a p-value of less than 0.001. This is less than 0.05, so it is low enough for us to conclude that in fact less than 50% are churchgoers. We can conclude this with a reasonable certainty because our p-value is very small. Problem 4. For the last several years, the dropout in Dr. Hunt's statistics class has been about 12%. Last year, she taught an online course. Of the 354 students enrolled, 36 withdrew. Write an approximate 90% confidence interval for the percent that withdrew last year. I used StatCrunch. The number of withdrawals was 36, the sample size was 354, and the confidence interval is roughly 7% to 13.3%, rounded to 1 decimal place. Which hypothesis will test for a change in the dropout rate? Once again, the null hypothesis says no change, that the dropout rate is still 12%. We're just checking for a change, so that's a not equal to 12%. Does the confidence interval you established in Part A give any evidence of a change in the dropout rate? Well, we're comparing it to 12%, the ordinary dropout rate. 12% lies within our confidence interval. It's between 7% and 13.3%. So it's possible it's it's possible it's 12%. It's possible it hasn't changed. So there's no sufficient evidence of a change in dropout rate since 12% is included in the interval. Let's consider another example to go along with problem number 4. This one gives a different result. In the 1950s, approximately 3% of all heterosexuals had more than one partner. A random sample of 2,500 heterosexuals today reveal that 5.5% had more than one partner. Find a 95% confidence interval for the percent today. Now, if we want to use StatCrunch, they're going to ask us not the percent, 5.5% that had more than one partner, but the number in the sample that had more than one partner. So of the 2,500 people surveyed, 5.5% converted to a decimal yields 137.5 people. So when StatCrunch asks us the number of successes, we're going to tell it 137.5 out of 2,500. The 95% confidence interval goes from roughly 4.6% to 6.4% if we round to one decimal place. Does this interval give evidence of a change in the proportion of heterosexuals with more than one partner? Well, back in 1950s, it was 3%. 3% is below this confidence interval. It's not in the confidence interval. So it seems that there is strong evidence that there is a change since 3% is not in this confidence interval. Problem 5. It was reported in a journal that more than 6% of all college students suffer from anxiety disorder. You have a random sample of 1,901 college students, and 139 report that they suffer from an anxiety disorder. Which hypothesis could be used to test the journal article's claim? Well, the null hypothesis always includes an equal sign, so we're going to hypothesize that the true percent is 6%. But the journal thinks it's more than 6%, so the alternative will be greater than 6%. Verify that the conditions are met and find the p-value. The conditions are independence, whether one student has an anxiety order does not impact another. The sample is less than 10% of all college students. The sample size is large enough, and the sample was random. So all of the conditions are met. So I'm going to use StatCrunch to complete the analysis. There were 139 successes out of 1,901 observations. I'm going to choose the alternative to be greater than 0.06, and my p-value turns out to be 0.008, which is less than 0.05. So the p-value is 0.008. Would you agree with the journal's claim? Well, yes, since the p-value is less than 0.05, in fact a lot less, this provides strong evidence that the journal's report and claim is correct. Problem 6. The overall cancer rate among adult women is 20.6%. A research report looked at 567 obese women and found the cancer among them was 146, or 146 had cancer at some point in their life. Test an appropriate hypothesis and state your conclusion. Well, we're going to claim that the cancer rate among obese women is no different than the general population, that it is equal to 0.206. Versus the alternative that it is not equal to 206, because the statement of the problem just says, is it different? It doesn't say, is it greater than or less than? When I run the numbers through StatCrunch with the number of successes being 146, the number of observations being 567, we come up with a p-value of 0.0024, which is less than 0.05 and the z-score is positive. So we're going to be rejecting the null hypothesis. There is a difference in the cancer rate. And since the z-score is positive, this says that the cancer rate among obese women is higher than the general population. Problem 7. There is concern that there is an increase in the percent of college students who are smoking. The National Center for Health claimed back in 2004 that 20% of all college students smoked. A college conducted a study involving 1,800 of their students and found that 414 smoked. Is their experience from this study any evidence that smoking among college students has increased? So either it is the same as it was in 2004, namely 20%, or it has increased and is now bigger than 20%. We're going to use StatCrunch with the number of successes, 414, the number of observations, 1,800. We're going to choose the greater than alternative, and our p-value is very small, 0.0007. Since it is less than 0.05, we reject the null hypothesis. So there is evidence from this college study that it would be really highly unusual if the smoking rate for college students was still 20%. In fact, it is likely to be greater than 20%. Problem 8. An airline claims that it hardly ever overbooks its flights, and if they do, it's only about 2% of the time. A random survey of 1,200 passengers found that 22 had not been seated because the plane was overbooked. Do these results of the survey cast doubt on the airline's claim? So we're going to go along with the airline's claim that the passengers who experience flight delays due to overbooking is only 2%, versus the alternative that it is not equal to 2%. So we're going to use StatCrunch with a number of successes, 22, number of observations, 1,200. We're going to choose the not equal to alternative, and we get a p-value which is on the large side. It's 0.68. It's nowhere near less than 0.05. So we cannot reject the null hypothesis. There is no strong evidence that the airline's claim is incorrect or wrong. And finally, problem number 9. In Plymouth, Mass, where Plymouth, Mass, in fact, is located near a radioactive energy plant. The population of this town is 39,450. And in the past 5 years, 819 people have died of cancer. Cancer experts estimate that one would expect only 750 cancer deaths in this group. So is the observed cancer rate unusually high? Well, the cancer experts would expect 750 out of 39,450, and if we do that as a proportion, they would expect a cancer rate of only 0.019 or 1.9%. So is the cancer rate in Plymouth the same as they would have expected, the 1.9%, or is it different than the 1.9%? So we're going to put this through StatCrunch. The number of successes, or the number of cancer deaths, was 819 out of 39,450. A greater than alternative. Our p-value is small. It's 0.0052, which is less than 0.05. So we reject the null hypothesis. So this p-value is small enough to conclude that the cancer rate in Plymouth is unusually high. So does this prove that people living near a nuclear plant will get cancer, or that the nuclear plant causes cancer? No. All that we're saying is that the rate in Plymouth is high. We're not actually going so far as to stating that the cause is in fact the nuclear power plant. Statistics does not allow us to do that.